we learn about this
Learning the second one, second,
this one.
yeah.
Uh, in our last lesson, we learned about this normal force. Sometimes we call it normal reaction. It is the reaction of the object on the object. Okay, it is reaction on the object. It
Yes.
comes about due to the support given by the surface. The surface will give you a support, and that support is a normal reaction. In some books they call it N, some books they call it R. So both
Okay.
of them the same, normal reaction or normal force. Okay, so yeah, the first case we have seen is when an object is resting on a table, okay, on a flat horizontal table. Normal reaction means that the normal support is actually they call normal because it is 90 degrees to the surface, so it's 90 degrees.
Okay.
Now, in the second case, it's a bit different because we are pulling or pushing the object. Now, when we are pulling or pushing the object, the normal reaction will change. Now, because if let's say you are pushing and you are forcing the object downwards, so the normal reaction will be greater because not only it has to support the weight of the object, but it also has to oppose the pushing force downward. Oh, in another case, like in this case, when you are pulling the object, the actually when you pull it up, you are actually helping the normal force. You don't have to use
Right.
so much normal force. So the normal force will be a bit less. Okay. Now we are going to the next case. So the next case is about the normal force inside a lift. Inside a lift. Now, if the lift is not moving, that means we are considering this case. The leaf, the green box is actually the leaf, and the object is inside the leaf, right? In order to measure the normal reaction, probably you can put a blue balance there, this bathroom scale. So you can stand on top of the bathroom scale, or you just put the object on top of the bathroom scale, and you can see
Okay.
the weight of the object, right, which is the force provided by the normal reaction. Now, in the first case, when the object, sorry, when the lift is not moving, okay, when the
Okay.
lift is not moving, the normal reaction and the weight, they are the same, right? Not moving.
All right.
Okay. Now, let us consider the case when the leaf is moving upwards. Now, when the leaf, the green box which represents the leaf, which when it is moving upward, we can have three possible cases. The first case is if the leaf is accelerating upwards. That means it is moving upward with acceleration. The second case is the lift is still moving upward, but it is moving upward with a constant velocity. Now, in the third case, the lift is moving upwards, but it is slowing down, it is
Okay.
decelerating. So, all these three cases, the lift is moving upwards. It is either moving upward with acceleration, constant velocity, or deceleration. Now, in all these three cases, we would like to know what is the normal reaction on the object. Now, the reason why we want to study about this normal reaction is because this normal reaction is actually related to the frictional force. So the bigger the normal reaction, the bigger will be the grip of the surface on the object. So if the normal reaction is big, that means the frictional force, the grip on the object is very big. If the normal reaction is very small, that means the frictional force acting on the object will be small. Then the grip on the
Okay.
object is not so big. So this is the reason why we want to find out the normal reaction on the object. So in this case, we are looking at the normal reaction on the object inside the leaf that is moving upwards. Okay, now how to analyze this, the motion of this object inside a leaf? Now we can look at it by considering the net force. Maybe I need to tell you again about this net force. Now,
Mm-hmm.
when two forces they are acting on an object, one in one direction and
Okay.
another one in another direction. So when one force is bigger than another, then there will be a net force. Now, if the two forces acting on the object they are the same, then there will be no net force. The net force is zero. But if one force is bigger than the other, the excess force is the net force. Okay, so we
Okay.
look at this first case here. When the object is moving upward with acceleration, now we know that this net force is the one that produces acceleration. The net force, according to Newton's second law, is equals to the mass times the acceleration. So this is the net force. Now, if we look at this object inside the leaf, there are two forces acting on this brown color object here, on this brown color rectangular object here. The two forces, they are the normal reaction and the weight of the object. So these are the two forces. Now, if we say that overall, this object is moving upwards, although it's inside the leaf, it is moving upwards. So we know that the normal force must be bigger than the weight, bigger than the weight, because it is accelerating upwards. So the who is bigger? The normal force is bigger, or the weight is bigger. So we look at the acceleration is upwards. So the net force is upward. That means this normal reaction is bigger than the weight. So how to create an equation involving all these three forces? So the equation is like this. Ayo. Okay, the equation is like this. We look at the net force and we say that the net force MA is equals to the normal reaction minus the mg. Why normal reaction minus the mg? Because it is moving upwards. The normal reaction win. The normal reaction is bigger than the mg. Okay, so we have the net force MA equals to normal force minus mg. But we are interested in the normal force. So we make the normal force the subject of the formula. So we want,
Okay.
and we have to move the mg over to the other side. So the negative mg, you move to the other side, become positive mg. So we know that the normal force is the mg plus the ma. Now this means that the normal force is bigger than the weight. It is the weight plus the mass times the acceleration. So let's say you go inside a lift and when you press the button, ask the lift to go up, you will feel that uh, at the first at start, you can feel that it's heavier, right? So it is because of the bigger normal reaction. The normal reaction is actually you feel that your feet is pressing more against the floor of the lift, because that normal reaction is the weight plus the mass times acceleration.
Okay.
Okay, now the second case. Now the second case, if you are moving up with constant velocity, Now, we have learned that from the Newton's first law, if an object is moving with a constant velocity, it means that the net force is zero. That means all the forces, they balance one another. So you look at the net force is zero. Now, what are the two forces acting on it? They are the normal reaction and the mg. So the normal reaction minus the mg, which is supposed to be the net force, because they are moving upwards. So I use the normal force minus the mg, right? So same thing with the first case. The first case, because it's moving upward, so I use the normal force minus the mg is equals to the net force. So in this case, I also do the same thing. The normal force minus the mg, and this is equals to the net force. But the net force
Okay.
is zero. But the net force is zero because it's moving with constant velocity. So I move the mg over to the other side, then I know that the normal force is exactly the same as the mg, which is the weight. The mg is the weight of the object. So if the leaf is moving with constant velocity, it means that the normal reaction will be the same as the weight. Okay, so how we form the equation? We always use from the net force. The net force is the bigger force minus the smaller force. Okay, it depends on which direction it is moving. If it's moving upward, that means the upward force is bigger than the downward force. So we use the upward force minus the downward force. So you look at all these three cases, I use the upward force, which is the normal reaction, minus the weight, the mg. So in this case also the same. I start off with normal force minus mg, because if we are moving upwards, that means the upward force is bigger. So even in this third case, I say that the net force is the normal force minus the mg. We always start with normal force minus the mg. Why in all these three cases, normal minus mg, normal minus mg, normal minus mg? Because they are moving upwards. The normal is bigger than the mg. So I use normal minus the mg. So that is where how we start off the equation. We start off by saying that the net force is the normal force minus mg. All the three cases, they are the same. So normal force minus mg, normal force minus mg, normal force minus mg. The only difference is, in the first case, the normal force minus the mg is the ma, because they are moving in the upward direction. The second case, the normal force minus the mg is equals to zero, because the net force is zero. In the third case, the normal force minus the mg is still the net force. But this net force, because it is slowing down, so the net force is actually negative ma. The net force is actually negative ma. This is accelerating, so the net force is positive ma. So here the net force is negative ma. How to make the n the subject of the formula? You just move the mg over. It becomes mg minus ma. mg minus ma. Okay, it means that when the leaf is slowing down, when you are about to reach the level that you want, you move up. At the start, the leaf, you feel that your leg is pressing against the leaf, pressing harder against the leaf. Now, when you are about to reach the level that you want, the leaf will slow down. When the leaf slow down, you feel that your body is a bit lighter, because your leg is not pressing so much against the floor of the leaf anymore. So you feel as if you are lighter. So it is because of the normal reaction is less. Any questions so far?
No, no questions.
No question. Do you know how to start off? You start off by using the net force equals to normal reaction minus the weight. because they are moving upwards. So it's normal reaction minus the weight.